Hi class, this is our lesson on simplifying radicals, and this is the lesson that comes before we officially start chapter 8. So this is going to be some info. Part of it's kind of review, part of it's going to set us up for success as we get into chapter 8. Okay, so today we're going to be simplifying radicals, and the first thing we need to know is what is a radical. And a radical is just a symbol that means root. Now, you might recall a couple chapters ago, we did simplifying roots where we had different indexes, or the little number that goes like above the square root over here. Today we're going to be dealing just with square roots, so you're not going to see an index at all. We're going to just assume that it's 2. So everything you see today is going to be, we're just taking the square root. Now remember, when we take the square root, we're asking what number times itself 2 times gets us that number in that's under the radical. Now when we do this, we are aiming to have no perfect square factors under the radical. Now a perfect square, that would be some examples, like if I took 1 squared, I would get 1. If I took 2 squared, I would get 4. So those are a couple perfect squares. If I took 3 squared, I'd get 9. 4 squared gives me 16. 5 squared is 25. 6 squared, 36. 7 squared, 49. 8 squared is 64. 9 squared, 81. And 10 squared, 100. So those are my first 10 perfect squares. Okay, so these are going to be really important as we go about our work today. We're going to want to keep these in mind. Okay, so when we go to do examples like this, we are going to factor out the perfect square factor, and then we just square root it. So when we look at these, we're going to be looking for, okay, which of these perfect squares is a factor of my number that's under the radical? So right away, I hope hopefully you remember 24, the factor of 24 would be 4. So I can rewrite 24 as 4 times 6. I haven't changed anything. I'm just writing 24 as a product of 2 numbers, 4 times 6. 4 times 6 is 24. Haven't changed anything. Now I can go ahead and simplify this because I can take the square root of 4. Well, the square root of 4 is 2, so I'm going to write that on the outside. And then if you were to try to punch in the square root of 6 into your calculator, you'd get a really nasty decimal. And so what we want to do is we're going to just leave the square root of 6 alone. So my final simplified version would be 2 times the square root of 6. I was able to take the square root of 4, which is 2, so that gets to go on the outside then since I went ahead and took the square root. And then I'm not going to take the square root of 6. I'm going to just leave that written as it is because I don't want to deal with any decimals. I just want to simplify. Okay? So let's try a couple more of these. So when I do this, I want to think, okay, what of my perfect square factors, so remember this list we made here, are any of these factors of the number I'm dealing with? So factors of 32, I should hopefully know that I could rewrite 32 as 4 times 8. Okay. Now, I know, though, that 8 has another 4 in it, right? Because 4 times 2 is 8. So, that kind of changes my mind. I want to go with something bigger. So, if I look back at my list here, I should also know that not only is 4 a factor, but 16 is also a factor of 32. So I would want to choose to go with 2 times 16. I want to go with the biggest perfect square factor that I can. Now when I take the square root of 16, I get 4, and then I'm gonna just leave my square root of 2 as it is because again I get a big long decimal when I punch that in. So 4 times the square root of 2. Now you can always check and make sure you're done because whatever's left under your radical sign should not have any square factors in it. Okay, so let's try the next one then. So square root of 48. If I wanted to rewrite that, I'd look back at my list of perfect squares. And I want to go with the biggest one I can. And again, just like last time, I'm going to go with 16. Because 16 times 3 is 48. And then if I simplify that, my square root of 16 is 4. And then I can leave the square root of 3 alone. that would be my final answer. Okay, for the square root of 150, again, look at your list there. And remember, you want to go with the biggest one you can. And it looks like the biggest one I can do would be 25. So when I go to rewrite this, I know that 25 times 6 gets me back to 150. So if I take the square root of 25, I get 5. And then the square root of 6, I can leave alone because there's no other perfect squares in 6. Okay, and then 47 is a little bit of a tricky one, but 147 you can make it by taking 49 times 3. Okay, and 49 is my perfect square factor, so when I take the square root of 49, I'm left with 7. And then I'm going to leave my square root of 3 alone. So my final answer would be 7 times the square root of 7. Or, excuse me, 7 times the square root of 3. Alright, so then the other kind of problems you're going to see on today's lesson look like this, where we're taking the square root of 2 different numbers. So what you're going to do is you're going to multiply both of these numbers. So my product would be the square root of 40, since 5 times 8 is 40. And then, just like before, I'm going to simplify that. So I'm going to think, okay, what are my perfect squares of 40? And I believe that would be, I could do 4 times 10. So my square root of 4 would be 2, and then the square root of 10 I can leave alone. Okay. This next one's going to work the same way. I'm going to leave that 6 out in front, and then I'm going to multiply my 2 numbers under the radical. So 10 times 2 is 20. So I'll have 6 times the square root of 20, and then I want to simplify that square root of 20. So again, I want to look at my perfect square factors, and I know that I can get 20 by taking 4 times 5. So I'll have the square root of 4, which is 2, and then I'll leave my square root of 5 alone, and then what I do out in front here is I would multiply these two. So my final answer would be 12 times the square root of 5. Okay, and then the last one like this, I would multiply my outside numbers. So 2 times 7 is 14, and then I'm going to multiply what's under the radical. So I'd have the square root of 18. And then I want to go ahead and simplify that 18. Remember, you're going to look back at your list of perfect square factors there. Ask yourself, okay, which ones are factors of 18? Hopefully 9 stands out to you. So I'm going to rewrite that, leave that 14 alone. 2 times 9 gets me to 18. Okay, and then I've got my square root of 9. I can simplify to 3, and then leave my square root of 2 alone. And then for my final part, I would take 14 times 3, which should give me 42. And then I'll have times the square root of 2. Okay. Alright, and then for the last couple parts here, it says to simplify the square root of a quotient, remember quotient is division, we can find the square root of the numerator and the square root of the denominator. So on these ones, on the left-hand column here, basically this is just saying that you can also write a problem like this. You can write it like this. If I'm taking the square root of that whole fraction, I can separate it out. Take the square root of the top number, the numerator, and the square root of the denominator. So the square root of 100 is 10, and the square root of 36 is 6. So I'd be left with 10 over 6, and then if I simplify that, I'll have 5 over 3 for my final answer there. Okay, the next one, same kind of thing. I'm going to have just separate out my radicals, so square root of 25 over the square root of 9. Square root of 25 is 5. Square root of 9 is 3. Okay, and now this next one, I can do the same thing again. So I'll have the square root of 13 over the square root of 64. Now the square root of 13 is going to get you a nasty decimal because it's not a perfect square. And there's no perfect square factors in 13. So we're just going to leave that alone. We can't simplify that anymore. But the square root of 64 would leave us with 8. So that right there would be our final answer for that one. Okay, and then last but not least, we'll have the square root of 5 over the square root of 49. Just like that previous problem, there's no perfect square factors in 5, so we're going to just leave that as the square root of 5. Square root of 49 is 7. So there's our final answer there. Okay, and then the very last kind of problem you're going to see is ones where you need to rationalize the denominator. That just means that we can't have any square roots in the denominator. It's kind of frowned upon in math. So what we're going to do to get rid of that is we're going to multiply by the denominator. So I'm going to multiply both the top and the bottom by the square root of 7. So that way I'll be left with 5 times the square root of 7 on top. And then remember from our last rule that we learned, when we multiply these, I'll be left with the square root of 49. And then if I factor that out, the square root of 49 would be 7. So I'd have 5 times the square root of 7 over 7. Okay, same thing on this one. I'm going to multiply both my numerator and my denominator by the square root of 6. I'll be left with 7 times the square root of 6 up top. And then I'll have my square root of 36 on the bottom. Simplify that out. And I'm left with 7 times the square root of 6 over 6. Okay, and then last but not least, I'm going to do just like I did on that left-hand column there. Separate out my radical, take the square root of each one. My square root of 144 is 12, so I'm left with 12 over the square root of 5. Oops. And then for my last step, I need to rationalize the denominator. So I need to get rid of that radical in the denominator by multiplying. And I'll be left with 12 times the square root of 5 over the square root of 25. And simplify that square root of 25 to give you 5. So this is what my final answer should look like then. Alright, go ahead and try the worksheet on your own now. Remember to refer back to your notes and the notes answer key if you have any questions.